Hey there, this is Perseverance in humanoid hologram form. I am here to help. Welcome to the Hidden Harbour site, part of the Western Jezero Delta. Together, we'll explore an exciting drill core sample called Kukaklek core and its surrounding outcrop, Kukaklek Island. This site is located in a rock layer called the Shenandoah Formation within the Jezero crater. This core sample is also referred to as Sample 16. Since landing in Jezero crater, Perseverance have explored igneous rocks exposed in the crater floor and sedimentary rocks that formed in ancient lakes and delta systems. The main goals of the Mars 2020 mission are to understand if these ancient water-bearing environments were habitable by simple life forms, to search for any biosignatures, and to collect promising samples for potential Mars sample return. The Hidden Harbour site was studied because it probably is home to rocks that formed in water or contained a lot of water, and therefore possibly biosignatures. This whole area would have likely been underwater multiple times, a long time ago, and therefore preserves the history of different changing ancient environments. Your mission today is to examine this sample and evaluate what the mineral features and textures tell us about its geological and environmental history. Let's start by looking around to see what we have already learned about the Shenandoah Formation. You're currently positioned near the abrasion patch, where the Kukaklek core will be extracted from the Hidden Harbour outcrop. The immediate local area is called Yori Pass, in a wider local region called Cape Nukshak. Notice the layering of the surrounding bedrock and the white features, which are mineral-filled cracks known as veins. Feel free to move closer to inspect the veins and rock textures. In the distance, you can see a few points of interest. The big hill just over there is called Whale Mountain, a defining feature of the Western Delta Ridge. This part of the Shenandoah Formation is a large sedimentary deposit that contains laminated mudstone, sandstone, and conglomerate. To the right of it is where the Wildcat Ridge outcrop was studied, in a location called Hogwallow Flats. The samples collected there are viewed to have fine-grained sedimentary rocks, rich in sulfate minerals, organic molecules, and evidence of past aqueous activity. That is why they are considered as prime candidates for preserving potential biosignatures. Behind us, you can see where samples 14 and 15 were collected, called Shuyak and Magik from the Amalek outcrop. Those samples contained clay and carbonate minerals, which probably formed in a lake or river environment. Finally, off in the distance, you can see where the sample depot is located. This is where Perseverance has been dropping off samples for recollection in the future. The sample depot is often referred to as Three Forks, named due to three distinct water channels converging in the space long ago. So that's the Shenandoah Formation in a nutshell. Once again, we will be exploring the outcrop Kukaklek Island in front of us. When you are ready, interact with Perseverance to initiate a SuperCam laser scan. SuperCam is a sophisticated remote sensing instrument aboard the Perseverance rover, which is designed to analyze Mars's surface from a distance. By firing a high-intensity infrared laser, it scorches surfaces by up to 10,000 degrees Celsius. The resulting plasma emits light that can be evaluated to determine the chemical composition of a possible sample. Pretty cool, huh? Well, look at that. The scan results reveal detected sulfates in the infrared spectra, with an absence of hydration bands between 3,200 and 3,700 wave numbers in the Raman spectra. This indicates the presence of anhydrite, calcium sulfate, that has lost all of its crystal water. This is the same result measured from the Wildcat Ridge outcrops way over there. Fascinating. I wonder if they might be connected in some way. Let's keep going. The next step is to perform a small abrasion using the rotary percussive drill on the end of Perseverance's arm. This allows us to reveal a fresh, rocky surface underneath any dust and weathered layers and ensure a clean and stable area for further processing. It then allows us to take pictures of the abrasion patch using various instruments. When you are ready, interact with Perseverance to perform the abrasion. The abrasion is performed using a rotary percussive drill mounted on the end of the robotic arm you see extending. This piece will grind away a 5 centimeter wide circle of the rock surface. Dust and debris will then be cleared by a small puff from a helium tank. The arm will then photograph and scan the abrasion using 3 different instruments called Watson, Sherlock, and Pixel. Watson stands for Wide-Angle Topographic Sensor for Operations and Engineering. It is a high-resolution imaging system mounted on the end of the rover's robotic arm, designed for extreme close-up images. Sherlock stands for Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals. It is a scientific instrument aboard Perseverance designed to detect organic compounds and analyze fine-scale mineralogy. Pixel stands for Planetary Instrument for X-ray Lithochemistry. It is a microfocus X-ray fluorescence spectrometer designed to analyze the elemental composition of rocks and soils with high spatial resolution. We will explore the results of the scans from these instruments today too. Just in time, looks like our abrasion patch is finished up. Well, that's fascinating. The Watson and Sherlock scans have revealed a patch that contains a whole heap of white splotchy veins everywhere. That's funny, one of them even looks a bit like a fish. It's very likely these veins are composed of minerals precipitated from water and could provide some clues about Mars' past aqueous conditions and potential habitability. The pixel data will take a bit to analyze, so it might be nice to evaluate the sample a bit closer in the meantime. How about we morph into the abrasion patch at an appropriate scale and see everything close up? When you are ready, activate the morphing controls here. Whoa, this is cool. Hey, look, that's Perseverance above us up there. Pretty intimidating when we are this small. This is where Perseverance took the pixel scan from before, over the section that looks a bit like a fish. See this irregular white vein here? That's possibly a mass of calcium sulfate. It probably formed when fluids moved through these rocks in the subsurface after they were created. Why do you think these kinds of precipitates matter when thinking about biosignatures? Overall, this outcrop and the abrasion seem to be composed primarily of silt to fine sand-sized grains. A lot of these millimeter-scale veins are filled with calcium sulfate and mean that salt-rich fluids affected these rocks in the past. Aha! Our pixel data has been collected and analyzed. Let's take a look at the results using this analysis tool. The pixel data seems to reveal that the bulk of the rock is a mixture of mostly iron, magnesium, and sulfate. So we could be looking at grains of sand that were weathered from mountains outside of Jezero crater. It also seems to contain traces of an iron and magnesium silicate phase, likely a phyllosilicate, so something like the clays that form on Earth. And the veins are indeed made of a calcium and sulfur-rich mineral, probably anhydrite. This is similar to the outcrop at Wildcat Ridge. I wonder if there is some greater connection between the two locations. The fish-shaped sulfate zone indicates precipitation of these minerals in cracks. The crystal alignment is unusual here, indicative of fast nucleation rates or static recrystallization processes. It's possible that diffraction peaks may be observed in the X-ray spectra here. This is quite fascinating, and something to analyze in greater depth at some point in the future. Overall, this seems like it would be an excellent location to collect a full core sample. This is because we found clear evidence for water passing through a sedimentary rock. When you are ready, we can return to our normal size and proceed with the coring process. Perseverance will now take a full core sample from the outcrop. The core sample drilling takes quite some time, and sometimes multiple core samples are taken, usually in pairs. One of the paired samples usually gets stored inside Perseverance for safekeeping. Others are dropped off at the sample depot at 3 Forks that I pointed out behind us over there. Mars can be such a beautiful place. I cannot wait for people to come here and see it for themselves. So, it seems like this Kukaklek Island outcrop shares the same sedimentological and lithological characteristics as the ones at Wildcat Ridge, and is likely the lateral equivalent of it. At both Hogwallow Flats and here at Yori Pass, the outcrops seem to be composed of fine-grained, sulfate-cemented, planar laminated and low-angle cross-stratified sandstone and siltstone, intercalated with recessive and resistant meter-scale beds preserving soft sediment deformation structures. What does this mean? Well, it is possible that the outcrop here at Hidden Harbour and the ones at Wildcat Ridge were created when sediment from a river arrived at a large lake that was once present in Jezero crater. The sulfate-rich zones could be minerals that filled cracks in the lake bed that could have formed at varying times. While similar and possibly laterally connected, the veins in the two outcrops might have formed under different conditions. One just beneath the surface of the lake bottom, the other potentially much deeper. Further investigation will be required. The sample we have taken here is again an interesting mixture of iron, magnesium and sulfate, the composition of which suggests precipitation from salt-rich fluids. Evidence for microbial life could have been trapped within these crystals as they precipitated from water. This is one of the best samples we have for investigating whether life existed on Mars, so getting this sample home for further analysis is imperative. The question now is, where to go to from here? Based on the information available to you, where do you think we should head next? Interesting. I'll go on ahead then and take Ingenuity with me. We'll see you there in the future. Don't be gone long.